Yeah, look up. Here we go. Okay, no one talk. Okay, no one talk. Like all FRQs, this is laid out as follows. You're going to get a booklet, and then you're going to open the booklet, and it will show something like this. And there will be a problem like information here, and then it will be like part A, B, C, and D. And so the information never contains a question, just information. Temperature in degrees Celsius of the water in a pond is the differentiable function W. This little table is critical. So we did this last time, we'll do it again. Got to make sure you're keeping track of amount as opposed to rate, as opposed to the rate of the rate. So raise your hand, get some extra credit. Tell me, as you read this problem, you're reading about this function W. Does W belong here, here, or here? Hands up. Come on. You have to be able to properly identify what they're giving you in order to solve these problems. So we'll just keep practicing this. Where does W belong? So Zach?
The amount.
So W is simply a temperature. In degrees Celsius. So W is simply an amount of temperature. How many knew it? 0.2 for Zach. Question? Okay, hands up. Hey, what units go here? What units go here? Show your hands, come on. What units go here? Read the problem, figure out what units go here. On FRQs, you're often getting points for units, so you have to keep track of them. Find the plug. Okay. What units go here, Koji? Shoot. Christian, sorry. There, Koji walks in. Right? What units, Christian?
Is it days?
2 points, but no.
Okay.
Hey, look, everybody. Look. A rate always describes how fast this is changing. So the units here will always start out as being degrees Celsius, because this is going to tell you how this changes. So it's degrees Celsius per unit of time, in this case the time unit being days. So 2 for Christian. Who knew that before I said it? Point. Question? And then this column, hands, what units go here? Come on. Let's go, Julia.
Degrees Celsius over days squared.
Or degrees Celsius, either way. Or degrees Celsius per day. So. Question? 2 for Julia. How many knew it? Point. Okay. Yeah, please. Oh. In this particular case, the days are simply the way time is being specified. So I don't think of them as being an amount, rate, or rate of the rate. They're just how time is specified. So a lot of AP problems will describe how something is changing like every second, or every minute, or every year, or every day. So most commonly, the day is going to be the kind of the bottom part of the unit, the element of time. Good question, 2 points. Now? Okay. The student proposes the function P, given by this formula, as a model for the temperature of the water in the pond at time t. Hands up. Where does P belong in the table? Come on. Okay, don't talk. You cannot talk when I'm talking. Hands up. Where does P belong in the table? Gotta focus. Come on. Don't just take notes. Don't watch. Don't listen. Think with me. Like if you think with me, you will learn 10 times as much. Rachel. So Rachel votes to put a P here. Hands up. Who agrees with Rachel? point? 2 for Rachel. Who disagrees with Rachel? Kylie, talk to me.
Because it's the amount of the temperature. So I thought it was the amount.
P is still an amount. Because it specifically says a student proposes that the function P, given by this formula, basically be a model for the temperature of the water. So P and W are not exactly the same, but they are extremely related. W represents the idea, this happens all the time on the AP test. This paper is the appropriate color. There is a pond of water, blue. Somebody goes out to the pond every day, puts a thermometer in the pond, measures the temperature, writes down the temperature. That's where this comes from. Then somebody else says, oh, I can create a formula that will look like that. That's what P is. Okay, so they're both amounts. They're just two different ways of finding the temperature. Either use the formula or just look it up on the table. Question? How many knew that? 3 points. Okay. Please.
So would the rate be how fast the temperature is changing?
Perfect. Perfect. Look. It is a huge key to this class. Again, you can't talk when I talk. It messes me up. I lose my concentration. Like as soon as you turn to your neighbor and talk about something, I can't focus. We have the temperature of the water. This describes how fast the water temperature changes. So yes, P is the temperature of the water. P prime would be the rate at which the water temperature is changing. 2 for Carson. Other questions? So the problem says find P prime of 12. One thing you want to always do on the FRQ section, you got to make sure that as you're reading the FRQ, as soon as you encounter a question, you stop. FRQ problems, the entire FRQ is always worth 9. So whatever you see on these 2 pages, that's always going to add up to 9 points. How the points are distributed is not told to you. Now we've practiced the test so much you get a pretty good feel, but it's not a certainty. But I can tell you that one part of an FRQ, the highest point value I've ever seen, I believe, was 8. Like they literally made one part 8 out of 9. And then there was only a part B which was worth 1 point. That's the worst I've seen. Most commonly, each individual part is worth like 1, 2, or 3. It kind of varies. But what you want to do is reading the problem. If you find something to do, do it. Get those points. Even if you can't do anything else, you want to get all the points you can. So as soon as it says find P prime of 12, I'm stopping. And I'm going to just go find that and stop reading. Just find P prime of 12. Josh, talk to me.
I was going to say that, so it's like just instantaneous slope.
It is. It's the slope of this.
Yeah.
Yep. And because I can use my calculator, I can do that with my calculator. But when you use the calculator to find an integral or derivative, you have to indicate to the grader that you are doing that. So I have to write on my paper that I'm going to do this on my calculator. I'm going to find the derivative of P at time equal 12. So you have to write that on your paper. Otherwise, they won't give you the point. So every time you perform an integral or derivative with your calculator, make sure you write down what you're doing. Questions? Now it's as simple as grab the calculator. So here I did, I typed in P into my calculator. Make sure you use the fraction bar. Do not use the slash. So get get that entered on your calculator. Oh, please.
How do you do the fraction bar?
Fraction bar, no worries. Alpha and then y equal. Do you see it?
Do you do that after you do the negative x?
What I would do is I'd type 10xe. I'd pick, like I'll do it here actually, sorry. So I would have done 10x, and then I choose the e that's right here. So I get e to the something like that. Then I want a fraction, so I'll say alpha, and then y equal. Choose like that. Does that make sense? 2 points for asking. You would need to see that again. What do that mean? So that's just clear it. So I type, I'm just doing this part, is that okay, Sarah?
Yeah.
So I go 10x, I need e to something, so that's right here. Then I need the fraction, so that's alpha y equal. Anyone else need to see it? Cool. Once I have the formula typed in, I go back to the main screen. I do math 8. I think we did this earlier in the year. Like that. Just wave if you need me to do it again. And you need to come look at the calculator.
So like if you don't have your calculator, you have to just use the secant for the approximation.
Oh, good question. Let's get everyone to answer this one. 2 points for Josh for asking. Look at the board. Come on, all eyes on the board. If this were a question in the non-calculator section, don't do the work, but raise your hand if you know what work you should do to answer this question. You've done this before. This is reviewed. So if this question shows up in the non-calculator section, what are you going to do to answer the question? Kennedy?
Do you take the derivative of p and then you plug in 12 below?
Perfect. So you have to go from memory, of course, but you use the rules that you have practiced all last semester. You find the derivative of this formula using the green sheet rules, and once you have the formula for p prime, you then plug in 12. Perfect. How many knew it? 0.2 for Kennedy. Okay. What you're thinking of is if they say approximate. And that's what they actually do here. Right here, this one. So then just write down your answer. Again, reminder, you have to write what you're seeing on the board here. Technically, you don't need this, because these two symbols are exactly the same thing. But you need this one so you're telling the grader what you're doing. The grader sees this, he knows you picked up your calculator. The number is -0.549. No units on this one, so. Question? Please,
Sorry, why are there no units?
only because, hold on, that was really dumb. I was suddenly thinking of a problem we did at the end of last period, but there were no units. So. Yeah, definitely have units on this. Hands up, who knows the units? And don't ever take points unless you're not raising your hand. I use the hand raising to gauge how well we're doing. Carrie? So 2 points, but 2 ways you can think of the units. One is to kind of look at this table and figure out what did we just find. So we took the derivative of p. P was the amount. So the derivative of p is a rate. So that tells me the units have to be degrees Celsius per day. Another way you can find the units is to look here. The units of P are degrees Celsius. The units of time are days. So when you take the derivative, you're taking change in temperature divided by change in time. So how many knew the unit? Point. Yeah.
So if I'm writing like the units, like can I like sometimes just do like C divided by D, or do I have to do calculation and write day as well?
You do have to write the little degree symbol. So really need to write that. Yeah, they don't
But
want
per day, can I just write D?
No, they won't do that. Good question. There's quite a few things you can abbreviate, but I wouldn't abbreviate that one. So please.
So if this wasn't a calculated question, can you find like the slope by doing like 21 minus 24 over 15?
So what you're thinking of, yes, if they said, now they would change the wording. They would say approximate, and they wouldn't use P because P is this formula. They'd say something like approximate W prime of 12. And yes, then you would go to the table and say, oh, I'm going to use the table's values to calculate, how fast is W changing. Is that what you meant? Julia, anybody else? Okay, last part of the problem is right here. It says using appropriate units explain the meaning of your answer in terms of the water temperature. All of you need to grab a flashcard and you need to create this flashcard. So you need more cards. On the FRQ section of the AP test, it's quite common to have probably 2 to 3 questions where they suddenly use almost always this exact wording, using appropriate units explain the meaning of something. So when you see those words, it's a key phrase. That's why I want you to have a flashcard so that you have that key phrase in your mind. Using appropriate units explain the meaning. On the back of the flashcard, I'm going to write down that when I see this, I need an explanation for every number and unit that I see. Every time I see a number and unit, I need to explain that. And I have to remember that I have to use the words increasing or decreasing when necessary. I'll show an example here in a second. But the flashcard is just meant to remind you of what you have to do when they say using appropriate units explain the meaning. So, I'm watching everyone's pencil there for a minute. Okay, so back to here. Here's how I'm going to explain. The question is asking me to explain the meaning of my answer. So this is your answer. Look, remember this was part of what you had to write. So you're looking at this and trying to come up with words that describe this. So here's what I would write. What does all this mean? My answer is telling me that the temperature of the water. So here's an example, Chris, where it is okay to abbreviate. Temp is fine for temperature. The temperature of the water okay, my answer is telling me that the temperature of the water is decreasing. That's why your flashcard has this little reminder. Make sure you use the word increase or decrease if you need to. So, temperature of the water is decreasing. That's another place where abbreviation is legal. The temperature of the water is decreasing at a rate of .549 I wrote down a number, so I have to write down a unit that goes with the number. That's what the flashcard's reminding you of, that every number has to have a unit. So the temperature of the water is decreasing at a rate of 0.549 degrees Celsius per day. Okay, I want you to raise your hand here in 1 second, Mary. This explanation is incomplete, meaning you will not get the point. When they ask for an explanation, they're just going to give you 1 point or 0. Because I didn't follow my rule on the flashcard. I did not talk about every number and unit that is described in this equation. So hands up, what am I missing? Like with what I have written, I will not get full credit. In fact, I won't get a point at all. I'll just get 0. So Marin.
Did you say at time equals 12?
Perfect. And same thing here again, Marin. When I write down that number 12, I got to write units with it.
At time equals 12 days.
Right. So some way to modify this would be to say something like the temperature of the water on day 12 something like that is decreasing at a rate of 0.549 degrees Celsius per day. How many knew it? 0.3 for Mary. Good job. Questions? You really need me to explain anything differently? Please, Calvin.
This is like a small question. Is it valid to put a negative in front of the 0.549? Because that's our answer. I know we just like already say it's decreasing, but.
Good question. What they really want you to do is they want you to interpret the meaning of the negative. So when you said the word decreasing, that took care of the negative. So you wouldn't want to put the negative back in. That's why the flashcard's reminding you to use those words. So 2 points. Please.
Is it bad to put, like, for the units, the degrees Celsius over days, or is it, do we have to put
Per day.
Per day after that?
I think they're good either way. I kind of like writing it out more like an English sentence, just because they said explain the meaning. And I'm thinking of some other problems where writing out the words does make a bit more sense than, I think they're okay on that. Points. No? Awesome. Next one. This says find the average value in degrees Celsius of P over that time interval. That's just review from the yellow packet. So I'll let you do that at home as part of your homework. So moving on. Do number, this extra example, go. So do that one quick. Stop me if you have a question. Go. This is also review from the yellow, but Raise your hand if you have that written on your paper, please. Please raise your hand if that is written on your paper. 2 points. Question? This is okay because you decided to kind of do a computation. It's safer to stop here. Like remember, hey, every time you do an additional computation, you always risk a mistake. So if there's no requirement to do an additional computation, you really shouldn't. Just stop there. Points for any questions? Yes, please, Ashley.
This might be a dumb question, but you keep saying that, but I'm confused. Like when I know that I should stop.
You should stop. One thing that will help is we'll just keep practicing so many FRQs, you'll kind of get used to it. Like I'll keep reminding you.
Okay.
The basic rule is if all you're going to do from here to here is add, subtract, multiply, or divide, don't.
Okay.
Really. It feels weird because you're not used
it bothers
to
me.
it. Yeah. Like I got to go further, you know?
Yeah.
Yeah, it's just part of the AP test, and it is the smart thing to do.
Okay.
Because like I said, they don't require you to go further, so if you do go further, you're just taking a chance on a dumb error. Does that make sense? Yeah, just keep, Ashley, just keep asking. Like I want you to have full confidence that you're stopping in the right place, so just keep asking these. 2 points. Anybody else? Awesome. This is also review from the last packet, but take a minute and do that problem as well. Go.
It's like it should be 6 dx.
Okay, look at the board, please. Look at the board. Okay, as I keep saying, if you're working a problem and you need an integral, you have to write down the integral. Otherwise, you do risk losing points. So when they wanted the average of W, this is what I wrote first. So please raise your hand if that is written on your paper. Show your hands, come on. If not, don't raise your hand. But 2 points. Question?
You write 1/12 instead of 1/15 minus 3. Does that work?
Oh, if you have 1/12 here, totally fine. 2 points, Mary?
So for the FRQs, do you have to write average of W of T equals?
No. Yeah, this part's just me trying to help explain what we're talking about. You do have to have this. 2 points. Question? Like it asks for the average of W, so this is a flashcard number. You say, oh, to find the average of W, I need to integrate W multiplied by 1 over the duration of the integral. So, questions? Okay, this is Ashley's question now. Look, if I write this line, that's totally fine. It's not required. But as Ashley was asking a minute ago, you cannot stop on this line because there's more to do than just add, subtract, multiply, and divide. I need to go find the value of W6. So I have to find that value. Once I've written this line, now I can stop. Make sure you include the units. So. Question? Okay, cool. Skip number 3, you'll do that in homework. Skip 4, skip 5, go to the next extra example. So go to the next extra example. Okay, it says an object moves along the x-axis with initial position x of 0 equals 2. So you should draw on your paper this. X-axis, y-axis. This is the origin. Right here. But this particle is over here at location 2 when time is equal to 0. That's what the problem is saying. Questions? So once again, I want to make sure I keep track of when are they talking about an amount, when are they referring to a rate, or a rate of the rate. So please raise your hand and tell me where does this symbol belong in the table. Hands, come on. An object moves along the x-axis with initial position x of 0 equals 2. So where does that belong in the table? Let's go, Tori. So the position is an amount. They don't have units here, but common units would be meters, and then meters per second, and then meters per second squared. So the position is definitely the amount. It's the location of the particle. It's not a rate. How many knew it? 0.2 for Tori. Okay. Question? Then they give us the velocity of the object as being this equation. So that means we can use the equation to find the velocity of the object at many different times. At time equal 4, is the object speeding up or slowing down? Here's how you're going to figure that out. Watch me. I'm trying to describe this in a way that is really will feel like common sense, so the memory is really easy to recall. If I'm a moving particle and my velocity is positive, say out loud please, which way am I moving? Louder? Right. Good. My velocity is negative, which way am I moving? Left. Okay. If an object is moving to the left, and it's not speeding up or not slowing down, then you know for certain the acceleration of the object. Say it out loud. What is the acceleration of the object? 0. Question? Acceleration describes how the velocity changes. It's in the chart. The acceleration is the rate at which the velocity is changing. So if the velocity isn't changing, the particle has no acceleration. the particle is not speeding up or slowing down. If, however, let's do it this way first. Oh, several people were kind enough at Christmas to donate for a gift. So I have this nice gift now.
Oh my gosh, that's so funny.
I'm kind of self-conscious, well, actually very self-conscious. So wearing a hat does not, I don't wear hats very often, but I'll do my best. Plus, my circumference of my skull is rather large. So I've extended it out as far as it goes, and it's still a little bit small. Anyway, so do our best. So I am now the particle. Okay, all right. Feel like a little kid. Okay. Watch. So now y'all gonna have like in the AP test, like, I can see it. He's got the hat on. He's like, okay. So if I'm moving to the right, watch. And you have to remember, all these problems are idealized. I mean, there's no friction. There's nothing to stop my movement. I'm just moving to the right. If a force, think of it as the wind, okay? Like a force, like a wind starts to blow in the same direction, just say it out loud. Am I going to speed up or slow down? Speed up. Okay. The wind is what causes the acceleration, okay? So if I'm moving to the right and the wind is blowing to the right, would you guess that the acceleration is positive or negative? Say it. Positive. So if I'm moving to the right and the wind is blowing to the right, I'm going to speed up. So you need to have memorized this, that if the velocity is positive and the acceleration is also positive, the particle speeds up. Okay? If I'm moving to the left, say it out loud, please. Is my velocity positive or negative? Say it. Negative. Oh, boy, that was pathetic. If I'm moving to the left, is my velocity positive or negative? Say it.
Negative.
There we go. Negative. If the wind is blowing to the left, is the acceleration positive or negative? Say it. Negative.
Blowing to the left.
Yeah, that confuses everybody. Listen. Okay, the direction of the wind is the sign of the velocity, because acceleration and force are related by Newton's laws. So the particle's going this direction to the right. No, back up. Sorry. If the wind is blowing to the right, that's a force in that direction that causes an acceleration in that direction. So acceleration is positive. If the wind is blowing this way, okay, that's a negative acceleration. It's the direction of the acceleration is what's important. So if the particle is moving to the left, the velocity is, say it, negative. If the wind is blowing to the left, the acceleration is negative. Just use your common sense. The particle is moving to the left, and the wind is blowing to the left, speed up or slow down? Speeds up. So whenever the signs of velocity and acceleration are the same, the particle speeds up, because the motion is supported by the wind. Like I'm moving to the left, the wind makes me want to go more to the left. The acceleration and the wind are, it's that force that's connected. Question? Please.
So if they're like, if velocity is positive and acceleration is negative, that's when it is slowing down.
Slowing down because they're in opposition. So it's convenient that it's intuitive in that regard. But yeah, when the signs are opposite, the motion and the force are opposing each other. So the wind is going to, the force is going to slow the object down. So the velocity, the particle slows down. Usually the reason this confuses people is because prior to this moment, you have never talked about an object ever having a negative velocity or a negative acceleration. So it kind of messes with your intuition. But this is what you have to know. Questions? Okay. So when they ask you at a given instant, is the particle speeding up or slowing down? The only way you're going to get credit for this is to compare the velocity and acceleration. All other methods I've ever seen students use will not get any points. Okay? You've got to say the velocity at time 4 is. That's easy to find because you have the formula for velocity in your calculator. So you just grab your calculator. Make sure I got the right formula, so I've got to get the new formula here. So this is 2002 number 3. Okay, so now I have the correct formula. I go to the main screen of the calculator and I simply say I want the velocity, which is in y1. I want that velocity at time 4. Negative 0.866. Anyone need me to do that again? Just wave at me. Write that down. Question? Now I need to find the acceleration at time 4. To find the acceleration, I need to take the derivative of the velocity. So because I'm finding a derivative on my calculator, I have to use the notation to describe to the grader what I'm doing. So I must write that on my paper. I'm going to do a derivative on my calculator. I have to tell the grader what derivative am I doing. Question? Please.
We don't need the A points at 4 equals, right?
That one's not required. Because this means the same thing as acceleration. I kind of like writing it. It just makes me feel like I'm telling the grader what I'm doing. B of 4, A of 4. So I recommend that one. Then on your calculator, you hit Math 8. Like that. Questions? Well, it says I have to justify, I haven't answered the question yet, but I also have to justify my answer. So you need to have the following words on your paper. Since A of 4 and V of 4 are both negative, you may abbreviate negative. The object is speeding up, sorry. And just like Marin said previously, you want to indicate that the object is speeding up at t equal 4. So we give a good description. So. Questions? I'm going to give a full ticket for this one. You can feel free to talk to each other. I want to see how many people can answer this question. Full ticket for everyone who can do this. Okay, we keep talking about how we have an amount, we have a rate. The rate describes how the amount is changing, and then the rate of the rate describes how the rate is changing. So we have a good example of that here. Let's make the numbers a little bit. No, we can leave it like this. Again, no units on this page, so we're just going to pretend the units are meters per second. So this says the velocity. This is an easy ticket. Should have made it harder. Oh well. It says the velocity is negative 0.866 meters per second. The acceleration says that at that exact same moment, the velocity is going to be changing by negative 0.524 meters per second every time 1 second of time elapses. That's what acceleration means. So talk to each other and raise your hand, use your calculator if you need to. If the acceleration were to stay constant at this value for 3 seconds, raise your hand if you could tell me what would the velocity of the particle be at time 7. Now, I'm inventing a problem that doesn't really match this, because in this problem the acceleration is not constant. But to help you understand what we mean by amount, rate, and rate of the rate, this is a good example. We're saying at time equal 4, the velocity is negative 0.866 meters per second. Over the next 3 seconds, the acceleration, which is how much the velocity is going to change, is negative 0.524 meters per second every second. So talk to each other and raise your hand when you're ready to tell me what will the velocity be at time 7, if that's all true. Go. Full ticket if you can honestly get the answer and honestly say that you understand what's going on.
My calculator. Wait, so that I don't think
I did, so I did, I said like,
So I saw loss is how much the loss times the velocity is going to change every second.
Yeah, so we're finding the trends. And the acceleration is
Oh wait, no, yeah, you're right. Wait,
the acceleration means like the velocity will change by negative 0.524 every second.
I don't know if you added. I made my class tonight. So I think you might just.
That was just for 3 seconds. I don't know. That's just
Every
Okay, here we go. Raise your hand. You have a number to write here. There's a number they want to write here. If you don't raise your hand, you don't get the ticket. So no claiming the ticket if you don't raise your hand. There's a number they want to write here. Let's go, Sophie.
Negative 2.438.
Anyone have anything different? Who has this? Show your hand. Nicely done. Let me just talk through it real quick. Look. Pretty sure I heard Terry saying this really well. This number is telling you how this number is going to change. So this is saying that every time 1 second of time goes by, this number will become more negative. It's already negative 0.866, but every time 1 second goes by, it will become more negative by this amount. So if 3 seconds go by, I got to do 3 of these. So what Sophie did is she took 3 of these. They're still negative, so they make this that much more negative than it was. Questions? That's what you did, right?
Yeah.
Yeah. Okay, look at the numbers. They match up with what I was trying to demonstrate. The velocity is negative, so say it out loud. The particle is moving left. Good. Because the acceleration is negative, it's like a wind is blowing to the left as well. And it's causing the acceleration to become more negative. Therefore, the particle is speeding up as it moves left. Questions? Hands up if you feel like you deserve the ticket. Mark down 10. Good work. Questions here? Anything? Cool. Next one. Okay, next example says at time equal 4, is the object moving toward the origin or away from the origin? So, simple idea. Here's our picture. Here's the origin. At time equals 0, the particle is over here at location 2. We want to know at time equal 4 whether the particle is moving towards or away from the origin. The previous problem gave us a head start because we know that v of 4 is a value of negative 0.866. So we know that at time equal 4, the particle is moving left. We now just need to figure out at time equal 4, is the particle here? In which case, negative velocity would cause the particle to move away from the origin. Or at time equal 4, is the particle over here, which would cause a negative velocity to mean the particle is moving towards the origin. Wade, if you need me to talk through that again. So again, the idea is if this is the origin, and at time equal 4, I'm over here somewhere, but my velocity is negative, I'm moving that way, so I'm going away from the origin. Here's the origin again. At time equal 4, if I'm over here somewhere, and my velocity is negative, I'm moving towards the origin. Other questions? Full? So I need to find the position at time equal 4. The buff packet had not only example problems, it also had some explanation. We need that information from the buff packet, so as you're doing your homework, refer back to that if you need to. In the buff packet, we talked about the fundamental theorem of calculus, which says if I integrate velocity over some time period, the result of that integral, in fact, let's do that first real quick. So on my calculator, I can do this integral. So I just say math 9, 0 to 4, integrate velocity. Oh, shoot. That didn't work. Math 9, 0 to 4, velocity, like that. Okay, on the buff packet, we learned that the integral of the velocity gives you the displacement of the particle. So that's telling you that here, 1.432. So during those 4 seconds, however the particle moved, I don't really care, but I know the particle has displaced by that amount. That's how different the new position is from the previous. So the fundamental theorem said this is equal to your change in position. X of 4 subtract x of 0. So if I want to find x of 4, all I have to do is say x of 4 must equal whatever the position is at time 0 plus how much is the particle's position how much did the particle's position change? like that. So that means x of 4 is going to equal 2 plus 1.432. Therefore, x of 4 equals 3.432. Questions? Cool. To get credit on this problem, you do have to show the integral. If you don't show the integral, they'll take away points. So make sure you show the integral. Now I've solved it. I know that at time 4, the particle is over here. And at that moment, the particle has a negative velocity, so I'm moving towards the origin. I just need to answer the question and justify my answer. So you should write on your paper these words. Since the position at time 4 is positive and the velocity at time 4 is negative, the particle or the object is moving towards the origin at time equal 4. That problem is probably worth 3 points on the FRQ. So. Questions? Anyone want to talk about it more? Cool. Next thing. This is just review from the yellow. It says calculate the average velocity of the object. So to calculate average velocity, I integrate velocity multiplied by 1 over the duration of the integral. Just type it in my calculator. So you write that down if you need an extra example. The extra examples don't have answers in the back. That's why I try to get them all done in class. But questions? Oh, please.
If I were to write average like AVG, on the test, would that be with the point writing?
This part here?
Yes.
No, that's not required at all. They do want to see this. Same rule as always. If you're going to do an integral, make sure you write the integral. 2 points for Kennedy. Anyone else? Please.
Do you put an equal sign there instead of the about sign?
I just have kind of copied what the AP scoring guide says, and even though the calculator is not doing it perfectly, apparently they assume it's good enough because they always use an equal sign, so that's what I do. 2 points. Anyone else? It's kind of like that thing, honestly, in pretty much every math class I've ever taken in my entire life, like physics or engineering class. The reality is that every time we round an answer, it changes from exact to approximate, but it's almost like the whole human race has agreed that, oh, close enough. We'll just say equals. So, good question. Anybody else? Awesome. So, next thing. It says calculate the average speed of the object. So on the buff packet, you had a little reminder that speed is the absolute value of the velocity. So if I'm trying to find average speed, I need to integrate speed. And then I need to multiply by 1 over the duration of the integral, like that. Question?
Please, is it the same as this whole distance?
So if I take away the 1,
Take
oh,
away
actually,
the 1.
well, actually, oh, hold on. Maybe look at me. This is a really good question. Look at me. Points for everybody. What Josh is noticing is, if you cover up the 1/4, if you just integrate the absolute value of velocity, you're finding the total distance the particle travels, like how far in total the particle went. So let's grab our calculator and do that. There are more than one way to get absolute value on your calculator. My favorite is to take advantage of the fact that absolute value is spelled A-B, first 2 letters of the alphabet. The catalog in the calculator is a list of all functions. And since AB is very high on the list, it's actually the first one. So what I do is I want the integral, so I say math 9. I want to integrate from 0 to 4. And I want absolute value. So I say second catalog. And absolute value is first on the list. Now I want y1, which is my velocity. And then I want dx, of course. So 2.387. You get that typed in your calculator, then I want you to raise your hand and tell me, what does 2.387 represent? Looking for hands. What does 2.387 represent? What does 2.387 represent? Hoping for a few more hands. What does 2.387 represent in this problem? Let's go, Abby. How many knew that? 2 points, 3 for Abby. Look, this should make sense to you. If you know that in 4 seconds, the particle traveled a total distance of 2.3 meters, and then you divide that by 4 seconds, you have the particle's average speed. That's all you're doing. So right here, put in the 1/4. Just don't forget on your calculator to include the 1/4. 0.597 is the average speed. Questions? No units on this one, so no units are required. Yeah, no units given, no units are required. Please, Evan. Oh, no worries. You're good. Yeah, you're okay. That's right. Yeah, that's the way I like it. I just there's other ways. Anyone out? Okay, next thing. Do the next example on your own. Go. Do the next example on your own. Go. Stop me if you need to talk about it. Do the next example on your own, please. Stop me if you want to talk about it.
Oh, yeah, sorry. Oh, that's not supposed to.
Maybe that. Do the same thing,
Okay, look at the board, please. Okay. Everyone look at the board. Helping a couple of people, if you'll use, look, all of you, hey, this table, as we get more and more FRQs, it becomes increasingly important to make sure you know what belongs in each column. So hands up. In the context of this problem, what symbols belong in this column? Come on, hands. What symbols belong in this column? You have to get good at this chart. What symbols belong here? Let's go, Kenyon.
The position for the amount.
So the position belongs here. How many knew it? 0.2 for Kenyon. What belongs in this column? Come on, hands. What belongs here? Chris? So the velocity goes here. How many knew it? 0.2 for Chris. Now look at me. Here's how the chart, well, here's one way the chart is used. I've already kind of talked about how you use the chart to make sure you have the right units. You also use the chart to help you know what to do. Because the most common thing that happens on the AP test is students come to me and they say, I don't even know where to start. Like there's all this information, I don't really have a clue where to begin. The chart will help you. In this particular problem, they are giving you a position. At time 0, the position is 2. They're also giving you a formula for the velocity. Raise your hand and answer this. Which is more valuable, knowing the position at time 0 or knowing a formula for the velocity? Hands up, come on. Which is more valuable? Just use your common sense. Which is more valuable, a formula for the velocity or knowing a single position? Hands up. Which is more important? I mean, not more important. Which is more useful? Knowing that the particle's at position 2 at time 0 or knowing the velocity? Which is better? Kylie. How many agree with Kylie? 2 points. Because the formula for the velocity can be used to find the velocity at any time. So this is way more powerful than this. Look at me. So what they're giving you that's most useful is the velocity. And then they're asking for a position at time 3. So they're looking for this. So look at the chart. Look at the chart. Here's how you're going to use it. If you have a formula for position and you need the velocity, you're going this direction. That means you're going to be finding a derivative. Okay? But if you have a formula for velocity and you need to find this position, you're going to use the fundamental theorem. Okay, that's going to happen a lot on the AP test. Like you look at the chart and you figure out where am I, where do I need to go? So I got to go this way, so that's why you should be writing on your paper, the position at time 3 is going to be position at time 0 plus the integral from 0 to 3 of the velocity. And then you use your calculator to find that. So this turns out to be, this is 2, this integral, Sarah, what'd you get?
1.910. Or wait.
Yeah, that's right. So now she knows the position is 3.910. That's another way the chart will really, really help you keep from getting stuck or doing the wrong thing. Question? Cool. You're good. 1 minute till the bell. Good work. Homework is the glue. Your voice. Pretty good about it.
I've seen
This is the velocity. This is the acceleration. Acceleration tells you how stand over here. Looking here. This is the velocity of the particle. The velocity is always changing. But we can use the exact same idea we used for that other problem. So we get a trace of 0. The velocity starts out as, that means the velocity is here, the particle is not moving. This velocity tells us how fast the particle position changes. Where is that? Now I have a little bit of velocity. Somewhere. Where is the particle? It wants to move to the right. During this tiny the velocity more so the next tiny doing that. So when I integrate velocity in this time grid, I'm only figuring out well, the particle was here at 2. The particle is going to tell me the change in position. Like remember us talking about how it's 2 humanity. So the particle's here at 2. After 3 seconds, the position is changed by 1.910. That doesn't tell me where the particle is, it just says, oh, where it was, this is how different it is. Origin is the wrong word, but it's like where it was. Like it was at 2. It's moved 1.91 further to the right. That was perfect. That's really good. I want to make sure you write that down. The last part of what you said was the most important. And I didn't quite understand what you said the first time. I think I'm better now. Like we have this picture